Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to CHM421 Analytical Chemistry. This video we will discuss on topic 2, which is apparatus and techniques. As usual, I would like to start the discussion with the description of analytical chemistry. This course involves theory and techniques in analytical chemistry. Students will define the concept, explain the principle and application, solve qualitative and quantitative problems, and perform investigation via laboratory exercise. The outcome should be assessed through paper examination, tests and quizzes, laboratory skills, and laboratory report. This is the course learning outcomes. At the end of the course, students should be able to describe the function of laboratory apparatus, standard laboratory technique, as well as the principle involved in sampling in preparing laboratory samples. Explain the principles and application of volumetric, gravimetric, and basic chromatography analysis to solve the reliability of experimental data. Demonstrate the theories covered by performing experiments on volumetric titration, gravimetric analysis, and chromatography. At the end of the course, students also should be able to write a report on experimental findings in a scientific manner. This is the outline for topic 2. In this topic 2, we will learning about balance, volumetric glassware, water for laboratory use in heating apparatus, desiccator, filtration and titration apparatus and techniques, last but not least, reagents in purification of substance. For this particular video, I will discuss on the balance. Normally in the lab, we will use a balance to measure the mass or the weight of substance or chemicals that we use during the experiment. There are a few examples of balance normally found in the laboratory. First, electronic analytical balance. This is the typical balance that we found in our lab. We also can have mechanical analytical balance. This is the more conventional balance. It can be single pen or it can be equal arm. The third one is the less precise balance. We call it top pen balance because this balance less precise because they don't have a cover on top of it. In a specific, the types of analytical balance, we can have macro balance, we can have semi-macro analytical balance, micro analytical balance, single pen analytical balance, as well as electronic analytical balance. Normally, when we do the analysis during the experiment, we will take the reading of mass or weight within 4 or 5 significant figures. This is example of modern analytical balance. It most faster, in more convenient, and also more accurate. Safety procedure regarding the analytical balance. Student not allowed to use the balance at dangerous places. For example, dusty room, near with the gas supply, or near with the flammable fluid or solvent. Make sure when you're using the analytical balance, you handle it with care, and also don't try to dismantle whatever analytical balance you found in the lab. So for KNUs, the balance should be put on the stable support, for example, using the concrete bench. And also the balance should be placed in the air conditioning room. We don't want too high temperature surrounding it. And also do not place the balance directly in front the open window or under the air conditioning air vent, because this phenomenon will cause the drafting. Uh, the balance also should not be placed direct under the sunlight. Always handle the balance with the great care. Never drop the balance. Before we use whatever analytical balance during measurement of mass or weight in the lab, make sure we check the the balance, the level of analytical balance. So the bubble on the balance apparatus, it should be in the middle. This bubble, okay, it should be in the middle. If it's not aligned in the middle, we can adjust the screw under the balance to make the bubble place in the middle, like this. Uh, General rules for rigging. Before using the balance, it should be warm up at least for 30 minutes. Before we turning on the balance, make sure the doors are closed and the pen inside is not touching the draft rig. And then turn on the power switch. Never handle whatever samples to be weighed with finger. You can use tongs or finger pads to prevent the uptake of moisture by the dried sample. Center the sample that we want to weigh on the pen like this. Or we can use another weighing apparatus like weighing bottle or weighing dish or also weighing boat. But sometimes when we want to measure the mass of the solution, we're gonna to use a beaker. We weigh the sample using balanced at room temperature. Always allow the sample that has been heated to return to room temperature. This will also avoid the error due to the convection current caused by the hot sample. Never place the sample or the chemical directly on the pan. You weigh them using the vessel. As I mentioned just now, either you use the weighing bottle, uh, dish, board, or a small beaker. Always brush whatever spill sample of chemicals off immediately using a soft brush, and then close the balance door before making the weighing. A currents will cause the balance to be unsteady. So now weighing of solid, it can be carried out either direct weighing or weighing by different. If you want to do direct weighing, we use the weighing dish bottle of both to weigh the sample. The dish or the boot weighed empty, and then with the sample, and then this one is specifically for sample of non-hygroscopic. What is hygroscopic is the substance tend to absorb moisture from the air. And also we can do the weighing by different solid sample or chemical are usually weighed in dry in a weak bottle. Replicate the weighing most conveniently carry out by weighing by different. Also, if the sample hygroscopic, by using weighing by different with the bottle cap must be employed. So this one similar like I told you before on the previous slide. It just as you can see on the direct weighing. Uh, Direct weighing meaning that the object is placed directly on the balance in the mass plate. Usually we use the for stable solid or stable sample, non-hygroscopic or non-volatile liquid. And then we zero the balance. We put the container or the sample weight on the pan. We weigh the balance. We place the sample on the container, and the weight will be registered on the balance. Techniques of weighing by the difference is as I mentioned just now, weighing of solid can be direct weighing or can be weighing by different. The sample we for the sample weighing by different, the sample it should be in the weighing bottle is weighed. Then the portion is removed and quantitatively transferred to the vessel. The weighing bottle and the sample we reweigh in from different in which the weight sample can be calculated. The next sample is transferred in which is repeated to get weight by different. We also can weigh the liquid or all the solution using balance. Is quite similar with the direct weighing for solid. The liquid is transferred to the weighing bottle, which is kept to prevent any evaporation during the weighing. Then we do the weight. It can also be performed by weighing by different by pipetting out the olive wood from the weighing bottle. The inside of the pipette must be rinsed several times after transferring. Care should be taken not to lose any sample from the tip of the pipette during the transferring. So this one also similar with the previous slide. You can read it, weighing of liquid and solution. So now I will discuss several errors during weighing using the balance. Weighing in the vacuum is the most accurate. The weighing that meet on the balance normally will give the weight in air. When the sample displays its volume in A, it will void up the weight of A displays. So in most of the cases, the correction is not necessary because the error resulting from the buoyancy will cancel out in percent composition calculation. The same error will occur also in the numerator and denominator. Uh, Remember, all the weighing must be made with sample in the same type of container, meaning that a same density to keep the error constant. How to correct the buoyancy? Buoyancy error normally will affect the data if the density of the object being weighed differ significantly from the standard weight. This error has its origin in difference in the buoyant force exerted by the medium, normally A, on the object and on the weight. This is the formula uh, to calculate the weight of object in A can be corrected to the weight in vacuum. So vacuum, weight in vacuum corrected weight in vacuum corrected mass of the object equal to the weight observed in A plus weight observed in A multiplied the density of A over the density of A over the density of object minus density of A, density of A over density of weight. So, all right, as I mentioned just now, this is the error when we do the weighing by balance, which is the famous one is buoyancy error. In some time, we can have a temperature effect, but we not cover this type of error in this syllabus. So this is one of the example related to correction the buoyancy error that use the formula is mentioned on the previous slide. Uh, in this example, a bottle weigh with the 7.65 gram empty, and it increased 9.97 gram after filling with the organic liquid, which is the sample. This organic liquid has the density of 0.92 gram. The balance was equipped with the standard steel, which also have the density 8.0 gram centimeter cube. So the question is calculate the corrected mass of the organic liquid sample. So observe weight in A. The observed weight in A is the weight with sample minus with the empty weighing bottle. So we can obtain the weight in A. So the corrected mass, the weight in A plus weight in A multiplied with the density. The density of A over density of object, and density of A over density of weight. So 2.32 plus 2.32 0.012 over 0.92. This is the density of object, which is the sample, and 0.02 over 8.0. This is the density of the balance, the weight. So we can obtain the corrected mass of the organic liquid. Okay, that's all for this video. On the next video, we will continue with the volumetric glassware. Thank you very much. See you again on the next video.